I was asked to solve number 86, which says the tires of a car make 85 revolutions as the car reduces its speed uniformly from 90 kilometers per hour to 60 kilometers per hour. The tires have a diameter of 0.90 meters per second. Question A asks us, what was the angular acceleration of each tire? And question B asks us, if the car continues to decelerate at this rate, how much more time is required for it to stop? So if you come over here, you'll see the conversions that I already did out. So for theta, this is all our given information. Theta, we have 85 revolutions. However, we want to get the revolutions into radians. So to do that, we did this conversion here, and that got us 534.070 radians. To find, our next given was omega naught, and that was 90 kilometers per hour. So to find that in meters per second, we did this, 90 kilometers per hour times 0.277778 meters per second, and that got you 25 meters per second. And then we want that to be in the same unit as theta, so what we did was we divided the 25 meters per second by our radius here, which is 0.9, and that got us 27.78 radians per second. Our next given was omega, which is or final omega if you want to call it, 60 kilometers per hour. We did the same exact thing, multiplied that, and we got 16.67 meters per second. And then we divided that by 0.9, which is our radius, and we got 18.52 radians per second. Now back to the question. It asks us for the angular acceleration, which is what we're looking for there. So to do that, we know that we can find angular acceleration by doing omega squared minus omega naught squared over 2 theta, and that'll give you alpha, or angular acceleration. So we just plug in the numbers that we already converted, and the problem can be pretty simple from here. It's so it's going to be 18.52 squared minus 27.78 squared over 2 times 534.070, which of course are our theta, and it's going to come out to be our alpha. And you do that, you put that in your calculator, and it comes out to be negative 0.401 radians per second squared. So that's your answer to question A, and that is your angular acceleration. Okay, that's the question to. That's your answer to question A. And then we can flip it to the back here, and we'll do some work on the back for question B, which asks us how much more time is required for it to stop if it decelerates at a constant rate. So it's asking us for time, and we know to find time we have to do omega minus omega naught over alpha, which we just found. We just plug in the numbers from here. Again, 18.52 minus 27.78 over our angular acceleration, which we just found for part A, which is negative 0.401, and that'll give us time. And you do that in your calculator, you get 23.09 seconds, which is the answer to question B.